My name is Aron Semle, CTO at HighByte. Background is I came out of Kepware, worked at PCC for a bit, jumped into healthcare, got beat up, came back into manufacturing where it feels like home. I joined HighByte in 2020, and back then we were a very small outfit. It was basically John in a room talking about industrial DataOps to whoever would get on the phone with him. And I think 5% of people knew what he was talking about. So to get to this point where Sebastian's up here talking about the CAGR of industrial DataOps, not that long later, it's pretty amazing to see what's happened. All right. So I'm going to start with some use cases and I'll show you some demos, but we all arrive in industrial DataOps typically through the same pattern, right? There's some shared use case that we have, some shared goal across our enterprise. That could be, hey, we want to share information with our suppliers, right, to optimize supply. We want to be able to compare factory performance, factory 1 to factory 2 that are comparing that or making the same thing. We have a regulatory requirement on reporting, for example. So basically, we need to be able to get data in and out of our factories to drive business value. And that is when we hit the challenge of industrial DataOps. So why is that hard? Okay, so we go to factory 1, and it's like immaculate, right? Like they hired some intern 10 years ago that came in, and then they hired him, and he's this type A person or type A individual, and they just did a great job at organizing the data with a forward thinking, right? So you're pumped. You go to factory 2 to get the data. Looks like your teenager's room. It's a total mess. The data's in there, but like good luck finding it. There was no strategy. It's terrible. You go to factory 3, they're not even digital. They're running on paper, right? And this is the world that we're in. So why is that? So I like to kind of look back. So this is Bob, right? Bob is a controls engineer. He is responsible for getting a CNC machine online that needs to be in production next week. It's Friday, right? So he's in there wiring, programming the PLC, wiring up to the HMI, doing the work. In his head is, I got to get this done and get on the road to get to my kid's soccer game at 4 o'clock or my partner's going to kill me. He's not thinking in 10 years, this thing needs to be globally recognizable to my entire enterprise. He's not thinking that, right? And this is where we're at, right? So we have all this industrial equipment that is somewhat connected, but there was never this overarching data strategy in terms of how it had to interoperate. So brief history before DataOps. This is 2010. I'll call this 2010 to 2020. What were we doing? Rick is in the audience, so Rick knows ThingWorx. This was the age of the Industrial Internet of Things platform, IIoT. So ThingWorx was a great example of that. Predix was another example of that. God rest its soul. That one's gone. Solaire, other ones. Basically, it was the use of internet technology, bringing it into manufacturing. And it was trying to do the full stack, right? So we're going to collect data. We're going to contextualize it, store it, visualize it, analyze it, AR, VR, ML, the whole thing. And back then, I was at Kepware, and we had to take our industrial data and get it into these platforms. So how did we do that? We use this weird thing called JSON, which you probably know of now, but is this over here. So we took the very primitive representation we had of this data, which was tag data, and we literally just funneled it out. And if I show you, see if we can get the first demo is like an easy demo, so we can ease into it and kind of see how it goes. But this is what I would call a bad example. So what I'm showing you here is a pipeline in HighByte, and we won't go into the inners of this one. But I'm going to turn it on, and I'm basically just going to send raw tag data from an OPC server up to the cloud, in this case, AWS S3. So this is running, and we're sending that. Now, if I'm on the receiving end of this, so I'm in the cloud, I'm going to download it and show you what it looks like, just to kind of prove a point. If this is basically what we were doing. So here it is. In here, there is, let's see, tag HRM MTR X4. Anybody have any ideas on what that is? This is the challenge, right? I'm as far away from the equipment as possible, and this is the context that I had back in that era. And I personally experienced this. I had a brief gig at Schlumberger where I was consulting. We had many well sites that were doing fracking and everything else. We were pulling this data back into the cloud, and this is the view we had. And then we were contextualizing it, right? Trying to figure out what tags were what. And you do it once, and then you go to the next well site, and you'd be like, oh my gosh, it's totally different. And then you go to the next, and like, I'm going to look for another consulting gig. This is a terrible way to spend my day. It's hard. Right. So what the obvious thing was, well, we need to push that contextualization down towards the source of the data, which is what industrial DataOps is, or part of it. So if we look at 2020 plus, kind of when I joined HighByte and the team, And this is still happening today, but a lot of people knew that. We need to push the contextualization down. So what we're going to do is we're going to do it with custom code. All right, so we're going to write some Python scripts or whatever we need across factory 1, factory 2, and factory 3. The catch is these factories have different technology, right? So factory 1 has an ignition shop. Factory 2 is Kepware. Factory 3 is a Pi system, right? So they go in and they say, okay, we're going to write some custom code to contextualize this data and send it to the cloud in factory 1. Took us about 6 months to do the integration, write the code. Cool. Let's go to factory 2. Oh, wait, it's different. It's Kepware. That's going to take us another 6 months. Okay, go to factory 3. That's different. That's a Pi system. That's harder. 9 months. There's no scale, right? We're not getting faster as we go. What you're doing here is you're building an industrial DataOps platform and you don't know it, right? This is the same as like back in the 2000s if you were building your own HMI SCADA system. Today that sounds crazy, but that's what people were doing and some people are still doing. The other thing we'll see is people will use existing manufacturing software, right? So they'll say, let's use Ignition. First shop already had Ignition, so we're going to use Ignition for DataOps. Thumbs up, they don't care. We're already Ignition shop, fantastic, we'll use it some more. We're happy. Second shop is a Kepware shop, you bring in Ignition. They didn't have HMI SCADA anyway. They don't really care, still running their day-to-day, not a big deal, neutral. Third shop is a Pi system. They use Pi Vision. What you just started is a SCADA war inside Factory 3, and your goal was a shared use case around, energy monitoring or something, right? So trying to use these existing systems, again, very heterogeneous environment, and you run into trouble. So what is Industrial DataOps today? I think of Industrial DataOps as this API layer, right, that sits on top of the factory. And if Jeff Bezos had a famous memo in 2002, I believe, around, he sent it out and said, all the Amazon divisions have to expose their data through services, right? APIs, right? And one of the reasons, I don't know Jeff Bezos personally, but he's a smart guy. And what he realized is every one of my divisions uses different technology under the hood, and I'm not going to be able to go in and change that technology. But if I tell you in order to integrate with the rest of the organization, you need to share your data through a common API, then you can use whatever you want, and I have the interoperability that I need. Industrial DataOps is the same concept applied to manufacturing. And then so if you look at the IoT platform that's on the left, I think of Industrial DataOps as pieces of that platform now. That platform is now kind of expanded into, different companies take on different capabilities. Industrial DataOps is the collection, contextualization, interoperability of the old IoT platforms. All right, so let's get into a demo. So my use case is a Snowflake use case. So the business said we want to participate in a demand response program with the power company. This is national. I didn't plan this. National Grid did the demo, so this is actually kind of cool. But basically, we want to publicize our power usage data to the power company so that they can send us a signal when we should shut the equipment down if we want to save on power usage based on operations. How much are we going to make if the equipment's on versus how much do we save? The energy company pay us for like the virtual power we're saving if we shut it off. And we want to implement this across all 3 of our factories that have different systems. Remember, Ignition, Kepware, and Pi. All right, so the first part of that, so we'll go back into the hub. The first thing you need is a data model, right? So we have a use case. We need to share power data. What data do we need to share? So we call that models in HighByte. And here I have a use case model. And this one's going to be really simple, but it's just called power consumption. Now, I think we're going to talk about a different type of model in the next demo, but this is a contractual model. So we are not defining, we as the factory are not defining this model. This is defined by a business unit external to us that says, if you want to participate in this program, this is the shape of the data that we need for you to do that, right? Which is great because we don't have to create anything special. So in here, I just have the power in kilowatt hours, the machine status, is the machine on or off, the path, so where in the plant is it, and what plant is it in. So again, this is just very basic, but this is the data model. So if we bounce out, I'm going to do this in Ignition. So the factory 1 we're going to do. So now that I have my data model, the first thing I have to do is go connect into that system. And I'm going to use a filter here. I have all the factories implemented in one HighByte, but you can imagine these would be 3 separate HighByte instances. So the first thing I do is I have to connect to my data sources. So if I go to the Ignition Albany, this is a connection in HighByte. So we're connected out to Ignition. All of our connections support, browse, read, and write for the most part. So I can browse. I'm now looking at the tag provider if anyone's familiar with Ignition. So I'm looking at its address space. There's a fertilizer demo. And I've made this really easy for myself. So you can see this. Basically, pretend that we're a fertilizer company. So these are fertilizer factories. They have crushers, drum dryers, granulators, each lined up in a solid line of equipment to make fertilizer. So these are the assets that are in there and crushers, so we can browse that and bring that in. So we have connectivity to the source data. We have our data model. The second to last thing we need to do is actually create an instance in HighByte. So an instance is an instantiation of a model. And if we come in here under use cases, what I have to do is I have to apply that model to each one of my equipment. So you'll see in here I've modeled the crusher, the drum dryer, the granulator, etc. If you go in and look at what I did, this is an instance. So this is applying the power model to the crusher. And the model definition that we had before is down here. And now a lot of the magic of this and the hard part, I would say, is you've got to map that to the data sources. So if I go in here, I think we're in Portland. So I can go find this data source. No, that's not it. Thank you, John. I owe you one. So the Kepware Portland, so I can come in we were at Ignition. So I'm looking at all the sources of data that I have access to from HighByte, and what I'm doing is under the crusher, and again, I've made this naming really easy, I can literally drag and drop that into the model, right? And that hydrates the model. And these references in here, they can be simple references, or I can turn it into JavaScript expressions where I can mix and match attributes. I can manipulate the data, right? The beauty is once I've done that mapping and I go hit test instance, I go grab the data, I run it through the data model, and here it is. This is the shape of the data that I need to send to Snowflake. At this point, I don't care where the data came from. It came from Pi, Ignition, Kepware, you name it, right? So I go through that effort and I model my data, and then the last piece I need to do is just send it to Snowflake. So if I go out to I'm going to turn off the filter here. So if I go out to the power use case, again, these are all the factories. But what I can do is click in here. And this is a pipeline. So what we're going to do is decide how often we want to send the data. In this case, I'm saying every 10 seconds, go read all of those instances. It might be a little hard to see, but these are all the things we modeled there, and go send it to Snowflake. So if I go and turn this on, and then we just go up to Snowflake. Oh, don't make me log back in. Oh, no. Now we'll get through. I think it'll just drop me in without any two-factor. Yes. All right. Oh, these helpers, man. My team wants to add these to our product, and I'm like, no, don't do it. No. All right. Okay. And then I can so I'm basically going to query that database, and it's going to pull back, and we should see all the stuff coming from, we'll see the data model. So you can see here, this is the data model, so timestamp, path, plant, the power in kilowatts, et cetera. And I think you'll see some null things because I messed it up. But you'll see everything's coming from Albany, which is that Ignition plant. So likewise, I just did that for one plant. Now, the only difference with the other plants would be I've got to connect to Kepware and I've got to connect to Pi. So if we come in here and I go to the Kepware factory, which is factory 2, I create a Kepware connection, which is the same thing. We're just connected over OPC now, but we can browse. We can view the address space, and similarly, I just set up a fertilizer demo with all the same. And I won't walk through this, but then we go back to the instances and we drag in. Now, instead of hydrating from Ignition, we're hydrating from Kepware. We put it in the pipeline, ends up in Snowflake. We're part of the use case. So it's a use case-based data model, really simply, and Pi would be the same thing. It's kind of the same experience, right? So by doing that, we've enabled this DataOps layer. We've connected to the different sources. We standardized the data, and then we've moved that up into Snowflake. And then that's where the calculations are going to be run, in this case, against the data to decide. And then we'd have a signal that would be sent back to the factory, for example. I'm not going to demo that part. So that's basic. That's like use case modeling 101 in HighByte. The other type of data modeling is asset-based data modeling. And this is probably where most companies get stuck. I see Steve shaking his head in sales. Like, people get stuck here. What do I mean by this? If you're sitting around in a group and you're like, hey, we need to model a variable frequency drive, and someone asks who's going to consume it, and nobody answers that question, you are not use case-based modeling. You are in an academic exercise around what a variable frequency drive should look like, and you should leave the room as soon as you can because it's a giant waste of time. Jeff. it's not a waste of time, but companies get stuck here. They get stuck in, so asset-based models, when you think about that, it's organizing to the factory. So when I showed that image of this is the teenager's room that's a mess, it's cleaning up that mess. And it's beneficial for the factory to do that, but it's not required that all factories have the same exact asset models. I think over time we will get there, but we are not at a level of modeling maturity in our industry to start there. And when people try to start there and they conflate contractual models with asset models, they get stuck. So I'm going to show you what asset models look like in HighByte, and then how if you have an asset model, that allows me to enable that use case-based flow a lot faster. Okay. So what we're going to do is go and create some asset models. We'll organize them in a namespace, and we'll share this externally so you can see what it looks like. Oops. And then we'll get into some AI stuff because that's what y'all want to see. All right. So instead of use case-based models, I'm going to back out and we're going to look at, let's turn the filter off, asset models. And again, initially, we don't need to share these. We're just trying to organize our own data. So I'm a fertilizer plant, so I have a crusher, drum dryer, granulator. So I've gone in here and taken my best guess at this is the data that's in these systems, and this is how I want to contextualize it. So for the crusher, I have things like feed rate, the power, RPMs, vibration, etc. And then just like before, I already have connectivity to my OPC server where I'm going to do this, but I can go into assets. And let's look at the Kepware one. And I'm going to create instances of each one of those pieces of equipment using the asset model. So this is very similar to the use case-based model, but instead of modeling to the use case, I'm modeling to the asset. So you can see what I did is just like before, I went to inputs this time. And then went and found the fertilizer, and I hydrated this model. And then like before, when I read it, I get this nice contextualized data, and I don't care about the source of where it came from. Now what I need to do, John had mentioned this, is namespaces. So I want to logically organize these assets, either ISA 95 or whatever I choose to do, inside of my namespace. So in here, again, assume that I have this deployed across multiple factories. So this would be broken up. You wouldn't all see it in one instance of HighByte. But in here, you'll see I have Portland, line, and then I've laid out the crusher, the drum dryer, the granulator, and the mixer. And then when I do a test read of this thing, let me pop that panel. You'll see the data is all context. So I put it in a logical place and grouping, right? So this is my factory, this is my line, this is how I'm modeling my information in there. And now I can leverage that. So how would I do that? I'll show you a pipeline that's going to use that. So before, remember, I had a pipeline that grabbed all the instances and moved that to Snowflake. Well, if I have an asset model that I've standardized, at least inside my factory, I don't need to do that. So this is a pipeline that triggers once a second. It does something we call a smart query. So it's going to go in and reach into the namespace to say, give me everything under Portland. And then it has what we call a model stage that's going to model that data. So that if you looked at this model stage, what I'm really doing is I'm just going to reshape the data. So I know the shape of the asset model. I need to kind of reshape it into the usage model of power consumption. And I'm going to publish that out to Snowflake. So basically, in a single pipeline with a query, I can implement the same thing I did when I had to create all the instances in the pipeline before. And if I run this in debug mode, so debug mode is pretty sweet. So it's a way to view like what the pipeline's actually doing. So it takes off. I can see like before and after event for each stage. So as a developer, this is really helpful to kind of troubleshoot. So you can see I went and read 5 things. The number 5 here is the 5 assets that I have in that part of the tree of Portland line 1. And then I run each one through a model stage. And you can see on the left here is my asset model. On the right here is me reshaping it through the model stage to my model definition. And then I write it out to Snowflake just like before, and nothing else changes, right? So I sped up my ability to implement a use case because I'm not going down to it's called bare metal tags anymore. I've actually built up some contextualization of that data that I can then leverage to implement use cases faster. But remember asset-based modeling versus use case. And remember that question, who's the consumer? If there's no consumer, start asking more questions or leave. Because you could be in an academic exercise. All right, so let's start to look at AI. Looks like I got 30 minutes. We could burn more than that on AI. So we think of AI in 2 ways. So AI for DataOps and DataOps for AI. I'm going to start with AI for DataOps. So AI for DataOps is how I'm going to leverage AI to allow me to contextualize my factory data faster. Because a lot of the effort of a lot of the effort you spend in DataOps is trying to contextualize your data in your factory, depending on how much of a mess it is, right? So we can use AI to accelerate our ability to do that. And we think of that in the product as think of it as an automation slider. So everything I've showed you is totally manual, right? So I'm going to go in, point and click, drag and drop, and all that. Or I could go completely automated. I could go try to do it in an agent, generate JSON, and just bring it into the project. Or I could have it somewhere in the middle where the AI is going to do something. I can review it, accept, and iterate. So that's the way we think about. Oh no, I just exited the. Okay, we'll get back. So the example I'll give is instance generation. So if you remember, I kind of cruised over this, but what I've done is I've modeled all of my assets. So in here, I've got a crusher, and I spent the time to go look at the data sources and map it out. Say I've got 10 more of these in my factory, right? And they're similar, like there's some patterns in terms of where those exist in the OPC address space, but it's not exact. And it would be nice if AI could give me a hand to give a suggestion on that mapping so I don't have to go manually do it. So we have this feature called AI generate instances. And what it does is essentially think of this as a chat window that I'm going to open up with ChatGPT or whatever AI you use. What I'm going to give it is, this is the instance that I map. So I went and did the data mapping for this thing. Here's my primary example. And what I'm going to do is I'm going to bring in part of the address space, the OPC address space, that I know there's other instances of this thing in. So I give it the example. I give it the rest of the data source that I think there's other crushers in here. And then I say, go to town. And what it's doing, it's glorified pattern matching, right? It's going to look through the data source, the address of the OPC server. It's going to say, are there any other crushers in here? If there are, I'm going to try to map them. In step 2, I'm going to be able to review that. Depending on how Claude's doing today, we might get to, we got to step 2. Nice. So step 2, you can see it found 3 other crushers. And what this UI is showing you is that, you might not be able to see it, but this says line 2, right? So it found and I've made this really simple for the demo, but this can be more complex, right? The tag addressing the naming could be a little more obscure. But you can see under line 2, it's mapped this second instance to this part of the address space. Line 3, hopefully it's mapped to this. So I have the ability to kind of review what it did. I can test read that to make sure it looks right. I can make edits to it, but I've essentially auto-generated a bunch of instances based on the example that I gave it. So this is an example of using AI for DataOps to accelerate contextualization. We have a lot more examples of this coming. Like we just added a feature to generate pipelines using LLMs. That's coming in the next release. So you can communicate what you want to manipulate the data, and it'll come out with a pipeline that'll get you started. Is it going to be perfect? No. But is it enough to accelerate you by some percentage and make you more efficient? Yes. It's fun to play with, to be honest. Not in production. Do it in dev. But it's cool. I mean, that's AI for DataOps. Yeah, I botched the presentation, but I'm not a slides guy. The next one, I'll spend the rest of the time on DataOps for AI, right? So this is actually, when we looked at the CAGR of AI and DataOps together and the fact that they're maybe not linear, but they're both advancing rather fast, it's because, in my opinion, AI is a tailwind to DataOps in terms of market adoption, because to Sebastian's point, you need to contextualize your data to make AI useful at all, right? So what does that look like? So today, maybe I can do this. Yes. All right. Today, raise your hand if you're sick of chatbots, chatbot demos. Jeff is. Okay, I'm going to give you a chatbot demo. But you're seeing a lot of this, right? Because this is a really good example of how to... So we're seeing a lot of demos of chatbots, integrating that into some machine data and doing some interesting things. So what does that look like? And I'm going to spend a brief moment doing this. And the technology we're using to do this is called MCP, Model Context Protocol. HighByte can act as an MCP server, right? MCP, if you're not familiar with it, it's a way of exposing actions that an LLM can take, right? So either that's questions it can ask or operations it can do on data external to the LLM. In HighByte, what that means is if you look at my pipelines, our pipelines are essentially can become MCP tools. So under this MCP folder, I have tools that I've built specific to the agent that I want to consume them over MCP. And we'll start with these really simple ones. So I just have 2 that are browse machines and read machines. This is very generic, very chatbot-like tools. So browse machine, if you look at it, and I think we can run it so we can actually see it in debug mode. Oop, don't save it. It's going to use Smart Query, just like we saw. I used that in that second example of asset-based modeling. So it goes and grabs the namespace. It formats a list of paths. And then it returns, in the end, just all the lists of paths, the data paths in the namespace. And what that essentially is, If I pop back out, maybe not. These are all the unique, there we go, all the unique addresses it can read. So every path that's in here, basically I built a tool to say, go return all those paths. And then the second tool that I built is go read a path. So if you look at this one, it takes in a parameter, which is up here, a parameter that's the path you want to read, and then the LLM can. So if I expose this to a large language model, it has the ability to go read, what's in the factory, and I'm going to go read the current state of that factory. So to demo this real quick, I'm going to use just anything LLM. So what I've done is I've connected this to HighByte's MCP server, and what I can do is ask simple questions, and you got to type agent, but I'll say, this is why I hate chatbot demos. They don't show well, but I want to show the concept. Oh, there we go. There's our first failure. Let's go. So HighByte should be connected as an MCP tool. There it is. So you can see these are, so I'm in anything LLM, which is an agent essentially. And you can see these are the tools that I've exposed that have HighByte. So I have a bunch of them that'll be, a lot of these are in the second demo, but specifically browse machines and read machine is in here. So if I jump back and we try that one more time. Oh, don't make me type it again. This keyboard's also really weird. The first DataOps days I did this and someone came up and they said it's literally that easy to get manufacturing data into LLMs. And I'm like, yeah, it's that easy. And then it turned into, or accelerated a sale. So that's why I'm doing it, Steve. But you can see it went in and it's basically showing you Portland, Albany, basically that namespace we were looking at. And then I can say, read the crusher. I'm going to mistype it here in Portland. That's terrible, huh? It's going to figure it out. That's the beauty of it's making us all really lazy, these LLMs. But you can see it's going out and making a tool call. It looks like it's rebrowsing. So it actually made multiple iterations there. It browsed and tried to read the wrong path, and then you can see it read the right one. So it self-corrected. But you can see it actually returned the data for that. So I have the data that's in the LLM. This is cool. What I think is cooler, and I can't show you like how I generated this, but I pulled up Claude earlier and I said, hey, using those same tools, I want you to build a user visualization around my fertilizer plant. And I'll show you what it came up with. This, which, it looks a little bit like Nintendo or Super Nintendo. But, this is interesting, right? This is actually what it did is it went and built, it called the MCP tool to get the shape of the data and the context, and then it built HTML to show that, right? And then what I told it to do is because our MCP tools are also exposed over the REST API, which means you can access the same data over REST, the HTML can talk JavaScript and talk REST. So it built the connector into HighByte to go pull that data. So what you're seeing is the live data trending here. And I did it in 3 or 4 minutes talking to Claude Code with like 1 or 2 iterations. The first iteration looked really bad. And I was like, can you make it look like a little bit better? And it came up with this. This is probably good enough for this demo. But this is really interesting. It doesn't mean I think HMI and SCADA is going away. I think like companies like Ignition, Tulip are going to adopt this kind of technology probably the fastest to allow you to use language to build these things inside their apps. But it's really interesting to see like if I give it a little bit of context, what I can actually go and build with very little effort and how that's going to transform industry. I personally think, once we get the data plane, DataOps layer defined, the problem we're going to have is that operators are going to be building these things. It's not going to be like professional. It's going to be people on the factory floor that are generating agents and apps. And our challenge as an industry is like, how are we going to manage that? And then how are we going to pluck out the ones that add a lot of value and scale it across our enterprise for the rest of our factories, right? But this is the future of how easy it is once I have contextualized data to make it, to do some cool things with it. Okay, so with that, let's finally end on not chatbots, but agentic AI. So what I want to show you here is an agentic AI use case. And the point of agentic AI is the main thing to take away is it scales down. What that means is we've all had experiences where we're in ChatGPT and we're chatting and we're like 5 or 6 prompts in and things just start going sideways, right? And once they do, it's kind of like airline travel. Like it's not getting better, right? It's only going to get worse from here. So we cancel out and we start a new chat window. What's happening there is as the context, which is the chat window, builds, it gets larger, the LLM is more likely to hallucinate, right? Which means it's going to come up with incorrect information. So what we do in the agentic game is to say that rather than have one big chat window, I'm going to split it up around multiple agents. Each agent is going to have its own little chat window. And by doing that, we're going to reduce the context of each chat to try to get more reproducible results. What that means in practice in this example is, say I have a single CNC machine, it's not going to be a single agent trying to manage that whole machine. It's going to be many agents coordinated with very specialized tasks on that machine. And the reason for that is that, so we're up against math, right? So if you look at, the problem is with each one of those iterations, each thing you enter into ChatGPT, there's a likelihood of failure, like a failed response. Even if that likelihood of success is 95%, 20 iterations in is 95% times 20 times. Now we're down at 36% success rate. So that's the math we're up against in terms of compounding failures with LLMs and why we need to shrink them down. And you can't fight math for the most part. So this is the architecture, I think, of the future in terms of agentic AI, right? You have the DataOps layer, which we are focused on, Industrial DataOps. So I want to contextualize my data and expose tooling, like very specific tools that these very specific agents can use, because I don't want to give an agent access to my entire SAP system, for example, right? If that agent just needs to go create or make procurement requests, I need to give it very tailored, specific tools to do that. A, it increases security, right? B, it makes it like more likely to accomplish its task, right? So it's the specificity is really important. And then this agentic platform layer, I would argue it doesn't completely exist today. It's emerging, right? But to show you the demo that I'm going to do, I'm actually going to build it because that's the only way I can really do it. So basically, we're going to go off on a use case. And what we're going to try to do is predict. We're going to try to detect if one of the machines failed. And from that, we're going to generate a maintenance work order, or we're going to try. And to get this started, I'm going to launch my own agentic AI platform. So just watch out. I'm not getting hacked here. This is going to take a minute to fire up. But essentially, I'm launching like a bunch of agents locally on my machine, right, is the way to think about this. And what I've done in HighByte while this is launching is it's 3 agents, so it's not a ton of them. But what I've done in HighByte, if you go under MCP tools, is I built tooling out, machine-specific tools and maintenance-specific tools. So I have a machine agent that's responsible for it, and I've focused this on the crusher. But go get the current state of the crusher is what this tool does. Really simple tool. And this other one says go get the history of the crusher. So I'm pushing this history into OSI Soft Pi, and this is just going to go read out like a 10-minute chunk of history from this thing. And while that's spinning up, I'm actually going to put the crusher into error, because if I didn't, this demo would be pretty lame. So I'm actually simulating all this data, so bear with me quick. So it's going to go from good to bad. And really, in my simulated data, what this is doing is think of like crusher has a big hopper of material that's coming in, and I'm just going to slam that with material. So think of like the operators end of day, they're trying to get out of there, they're trying to maximize production. I'm going to overload the machine, right, which is going to put it into an alarm state and cause the heat and the vibration to increase. So I did that in my simulated data. I'm going to bounce back out. I'm going to briefly show you, this is the new version of HighByte. I think we just went to code freeze yesterday, so we're releasing October 22nd. Sounds good. So it's coming out soon. One of the things you'll see, John would kill me if I didn't show this. I have a few minutes. There is a dashboard. Oh my gosh. John, I'm so sorry. This is why I didn't demo on 4.3. It's going through regression in QA now. I might have swamped my machine with the agents. We'll see if we can get back to that during the Q&A. But it's got a cool dashboard. And the other thing we built out is MCP services, which I was also going to show, which is a view of, like right now, the MCP services are all buried in pipelines, but we'll have an MCP services tab where you can see these are all the tools that we're exposing, and here's a place where you can manage those tools centrally. All right. Well, with that down, let's see. Okay. What I'm about to show you is not a HighByte product, so don't. We're not going to be an agentic platform as far as I'm concerned. Like we're focused on DataOps, but this is the agent that I had to build to show you how this works. There is a chat interface on this agent because you need to visually see what it's doing. Otherwise, this would be a really lame demo. So what I'm going to do is I'm going to feed a set of instructions, which we're not going to read through. If I can copy paste. Yes. All right. So what I'm feeding it in is instructions to say, this is what I want you to do. Essentially, it's like, go look at the current state of the machine, try to figure out if there's an error with the crusher. If there is, go look at the history of the crusher to try to figure out why it's an error. If you think it's bad enough, go look at the maintenance work orders on that thing to see if there's already something open for it. If there's not, go and create a maintenance work order to let maintenance know they need to fix the machine and give some indication as to why you think it should be fixed or what's wrong with it. So you can see when I put that in alarm, there is a part over here that shows there is an alarm currently on the crusher, right? So that's showing up in that screen that AI built. If I can get around this. On the right here, you have the agents that I've launched. So if you looked at the scripts I ran, this is the maintenance agent that's running in its own process, managing its own context window. This is the machine agent that's doing the same thing. And then this is an orchestration agent. So think of this as like a pyramid, right? There's an orchestrator and two agents. One's responsible for machine status, one's responsible for maintenance. And on the right here is those agents that are connected. And it's a protocol called agent to agent to do this. But other than knowing that name, you don't have to worry too much about it yet. And what this is showing is the tools from HighByte that each one of those agents has access to. So the maintenance agent can go create maintenance work orders and get maintenance work orders. Those are going through HighByte. Machine agent can go get the current state of the crusher and get the history. So when I hit go, the orchestrator agent is going to break my steps into instructions, which they kind of already are. So I've given it a hint. And it's going to show you visually as it runs through the instructions. And on the right here, you're seeing that it's reaching out to the sub-agent to go get the current state. Now it's reaching out to go get the history. It's summarizing the result and the pain here. It's calling the maintenance agent. It looks like I have a bug there because it's calling both tools at the same time, but it's only going to call one at a time, obviously. And then it summarizes. Now, it's not really important to see the summary, but it comes through and it says, yeah, there is an alarm, triggered an alarm condition. Historical data indicates there was a surge in feed rate. So it was able to figure out that the feed rate went up, and it gives me a timestamp. We'd have to go validate to make sure that timestamp is correct, right? Like trust but verify, that caused an increase in power and vibration. So that's mostly accurate. It went and looked if there's an open work order. There's not. So it went and created the work order. And you say port and crusher is currently an alarm, and it gave the information. And I should show the work order here so you can see, say crusher alarm triggered, overload condition, historical data indicates a surge in feed rate. And that would create, the maintenance work order. So like that's the future of where we're going, right? And I had to do a lot of tech to get there, but like pretty soon that's going to be out of the box, out of the box behavior of like an analytics platform and a data operations platform like HighByte. You're going to want to use HighByte to control that data layer and expose the tooling, just the information that those agents need. HighByte can also audit what tools the agent's calling and all those kind of things. And it won't be running off batch scripts off my PC, hopefully pretty soon. Like I'm pretty excited to get the first like real agentic demo with an agentic platform. I could have used Agent Core from AWS to show the orchestration of this, and it would have showed the audit of like all the calls that were made. So it would have made me create less in that visualization for you to see, and help me orchestrate some of the agent interoperability. But that's the end of my demo. And let me just for John's sake, let's just see. You know what, John? I killed it. It's not even running. Yeah, so that's it. How much time? If you want to start answering questions, I can get this running. If you want to kick off questions, Tori or Anna. There's a lot there. It's firing up, but I think my machine is bogged down by agents. Yeah. Yeah, somebody bail me out. Chris.
So this may not be good. Okay, so what are the things you were pulling in a contractual model in one of your demo, like a very simple one? Are there any plans, or is it possible to pull that contractual model in from another system? Like, let's say somebody's got some JSON schema defined in some external system. Can you just pull that into HighByte?
Yeah, so in 4.3, we added support for OPC UA node sets. which is not a small lift. And I wouldn't personally say you should even use those for those contractual models because they are pretty verbose. But it's just an example of, yeah, we don't want to own the data models. Like we think those should be owned by your org, specific to you, probably backed up and get to your point in whatever format you're most comfortable with, and we would ingest those and allow you to operationalize those. But the node sets is like the first example of one of the. And the other cool feature, I think it just fired up. I don't know if I'll be able to show that in 4.3 is you can point to a data source and then just create a model from it. So if I've created connectivity to a SQL database and I just say, just give me a model to start with, off that schema, you can do it now in 4.3, which I think support said, or our internal support said, was their favorite feature, which was a bit disappointing because there's so much in there. But at the same time, I get it. So this is the dashboard. I didn't have version 4.3 running. That's why we didn't see anything. I'd shut it down. But you'll see like performance and write statistics and things. And the other thing you'll see in 4.3 is the MCP services. So when I was jumping around in pipelines, it's kind of hard to see, oh, this pipeline is just moving data to Snowflake versus this one is a tool for MCP. So we'll kind of bring that up. So from this view, I can see these are all the tools that I was exposing to the AI agents, and you'll be able to govern those from this kind of central pane. And we'll also have some out-of-the-box tools and some other cool stuff we're doing. Yeah, so there's this new import model option, Chris, here, and this is where you can either select a data source that you connected to and or node set, but this will allow you to generate models from external sources.
Hey, Aaron.
Yeah.
Also, if you have an external model, there are APIs, right, that you can call to create a model. So if you wanted to write your own script or code to auto-generate models, and that's possible?
Yeah, through the config API. Yep.
Okay.
Yep. I know. It's a lot. And I was going pretty fast. I wanted to get back on track. So I think yeah.
So with a lot of these agents, right, they're going to be hitting the data source for using MCP, but it seems like that's on the front end for right now. But on the back end, when it comes to, I don't know if I'm phrasing it correctly, but when it comes to like knowledge graphs, right, and then mimicking almost like the experts via maybe a back end type of integration, how's like, what are your thoughts on that?
I don't totally. So we have an item to go start looking more at knowledge graphs. Like maybe our namespace feature starts to turn into what I was showing you for namespaces there, which is more just like I want to organize data. It turns into a knowledge graph. The thing I'm concerned about with knowledge graphs, or the question in my mind is like at the end of the day, what we're doing is we're generating text documents that we're feeding to large language models and getting interesting output, right? But it's literally a text document. Like everything, MCP is even just helping you build the chat window, right, through interactions. So a knowledge graph, although shown to be useful, like is a significant piece of technology that's been around a long time, and there's a cost to like building those knowledge graphs. So my question is like, how much really does a knowledge graph help you build a better text document? And if it is really useful, we'll look into supporting it, and like you'll see it probably maybe that belongs in the agentic layer as well. I don't really know, but it's an exploration item for us. Or is it just like, is it really fancy technology to ultimately build a text doc, and there's better ways to do it? And I'm being totally candid. Like I don't know the answer to that question, but I do think there's like the industry seems really enamored by knowledge graphs, but anybody that's an expert that I like try to nail down and get that answer to that question, I don't get like a great answer. So that's why like we just want to spend some time and look at it ourselves to see.
Okay. Well,
Yeah.
Another part kind of adjacent to that is a lot of the issue with maybe some of these new technologies is that there's a lack of standardization. So like, for example, in life sciences, they're definitely looking a lot into this knowledge graph concept, but they're like, it's really kind of the companies making up their own standards for now, but that could be maybe a company standard, but not so much an industry standard.
Yeah.
Right. So I saw like a lot of people were referencing here, ISA 95 is pretty good. It's, but it's missing XYZ. Are we as an industry, and this is more of an open question to everybody, are we as an industry like working together to make a clear standard for people to follow?
Probably not. Standards usually lag innovation, right? For good reason. Like anytime you see standards ahead of innovation, they usually slow it down. What I will say is like specific, not knowledge graph, because I'm not super proficient there yet. With MCP, I'm not seeing standards yet. But I think MCP will be one of the first areas for industrial you'll start to see standards. And the reason I think that is because the cost of training models is exponentially expensive, right? But if I can create a standard for industry or certain verticals around MCP tools, so the definitions of the data I need to expose for my industry, and I can train a model on those tools, like there's a significant incentive to do that because not everyone's going to be training their own models on their own tool set and definitions because it's cost prohibitive to do it, right? So that's an area that I think is an early sign, at least in the AI world, that standards will first be adopted. And I'm working with Sesame on an i3x standard, which is not MCP specific, but if you go to Sesame and look, i3x is the name of the standard, you'll see that's more of like an API on top of UNS or manufacturing. And we are starting to look at MCP as part of that. So that might be one of the areas it first emerges, but I think just the economics of it, standardizing around some MCP tool sets makes a lot of sense eventually, but no one's doing it yet.
Okay. I mean, for me, it's like a lot of people are like, because there's no standards, I'm just going to wait it out, let these guys figure it out, and then we'll come in when there's clear standards so we don't have to go through the pain of like the R&D, so to speak. Yeah.
Yeah. Not which I totally get. At the same time, a lot of people, even without standards, are seeing value out of agentic AI and AI workflows, right? So it's like, which side do you want to be on?
Yeah.
Yeah. Awesome.